Hi, everyone. So welcome to the second part, and hopefully now the technology will be friendly with us. So let's look at the problem question number 5 in the practice questions I gave you. So suppose a game has two possible outcomes. Either you win $5 or you lose $9. Right, and now the question is like, well, if the game is fair, what must the probability of winning be? Okay, so let's remember the game is fair. This means that the expected value is equal to 0. But how do we find the expected value? Well, remember I gave you a way to go about this in class. So let's do that. So there's two possible outcomes, and step one is to list all the possible outcomes, right? So we have, let's just call win and lose. Okay, let's do a little table. Then the way we set it up in class was, which I told you, was you have to write down the probability of each outcome. But this is exactly what we don't know, right? So let's just call the probability of winning be x and the probability of losing be 1 minus x. Okay, and then what? This is a probability. Then what's the next thing we need to write? It's what are the profits or losses that you get from each outcome. So you might call it these winnings, right? But remember that winnings might be negative. And so here, what are the winnings if you win? Well, I told you it's $5. And what are the winnings if you lose? It's negative $9, right? You lose $9, so it's negative $9. Then what do you have to do? Well, you have to multiply the probability of each outcome times the winning that you get. Right, so here, right, we'll just write it 5x. And over here, we have negative 9 times 1 minus x. And then usually, to find the expected value of the game, you sum up these two, and that's how you get the expected value of the game. But now I'm asking, what if the game is fair? What's the probability? So you know that by summing these up, right, the sum is equal to 0. So what do we have? So let's rewrite it here. So what we want is to find x when 5x plus minus 9 times 1 minus x is equal to 0. And now, right, this is just simple algebra. So you have 5x minus 9 plus 9x equals 0. And that's just the same as 14x equals 9. So x equals 9 over 14. And this is the probability of that you want. Now you can check this. If you don't believe me, the probability of winning, I'm telling you, is 9 over 14. If you don't believe me, what you can do now is write over here, write 9 over 14. The probability of losing, you should know, is 1 minus 9 over 14, meaning 5 over 14. And you shouldn't believe me that the sum is 0. You should calculate it for yourself. And then you will get that, in fact, the sum is equal to 0. So if the game is fair, what must the probability of winning be? It must be 9 over 14. So it makes sense, right? You win less, right? Of the two outcomes, when you win less than when you lose more. So you must think that it's more likely that you're going to win, right? And in fact, 9 over 14 is quite a bit more likely than 5 over 14. Okay, great. So let's move on to the last question. So consider the following game. I'm going to flip a coin, a fair coin. So that means that the probability of heads is equal to probability of tails, which is equal to 1/2, up to 3 times. If it comes up heads in the first toss, the game is over and you win $5. If it comes up heads for the first time on the second toss, you win $20 and the game is over. And if the first head comes up on the third toss, you win $300 and the game is over. Now, this just seems to be a one-sided game, but actually, if it comes up tails every time, you have to pay me X dollars. Now, what does X have to be for the game to be fair? And remember, for the game to be fair, this means that the expected value is equal to 0. So remember, let's rewrite. Step 1, we want to list all outcomes and their probabilities. And the winnings from each outcome, right? And remember, winnings can be also negative. That's step 1. Step 2 is we multiply the probability of each outcome times the winnings for that outcome. And step 3, and this is to find the expected value. And in step 3, what you do is you add each one of these, add each product for each outcome. And that's how you find the expected value. And now we have, we don't know one thing, right? We know all the probabilities, which we didn't in the last game. But now what we don't know is the winnings. And I'm asking, what should the winnings be if the game is going to be fair? So let's start with the outcomes. Okay, so I highlighted them, or excuse me, I underlined them. So one is that heads comes up on the first toss. So let's just write this as heads, or if you want, H1. Right, what's the probability of this outcome? Well, I told you over here that it's fair, and so it's just 1/2. And what are the winnings? Right, it actually doesn't matter if you're doing this from your perspective or mine. I'll just do it from yours. So what are the winnings? Well, you win plus $5. So let's just write plus 5. So, and here what we're going to do is we're going to do probability of the outcome times the winning. And so 1/2 times plus 5 is 2.5. All right, so we're done with one of the outcomes. Good. So the second outcome is, well, it comes heads for the first time on the second toss. So what does that mean? It means I couldn't be heads on the first toss. So in the first toss, it's tails, and then it's heads on the second toss. And what's the probability here? Well, it's actually still 1/2 the probability that lands tails, right? Because the coin is fair, and 1/2 again, because it's independent. It's a fair coin, and you're tossing it twice. The winnings here are not just 5, but they're 20. And so what's 1/2 times 1/2 times 20? What's 1/4 times 20, which is 5. Right, and we're done with this one. We have a third outcome, which is the first heads comes up on the third toss. Okay, so that means you get tails on the first toss, tails on the second toss, and heads on the third toss. And so now it's 1/2 times 1/2 times 1/2. So let's just write that as 1/2 times to the third. And that's just 1/8. And the winnings here are huge. It's plus 300. Okay, and so if you multiply 1/2 to the third times 300, what do you get? Well, you can get a calculator and you can see that it's 37.5. So are we done here? No, right? Because there's still one outcome, which is, which I haven't, it comes up tails every time. And this is where I win money. right? So now it's tails on the first toss, tails on the second, and tails on the third. And so what's the probability? Well, actually, these two have the same probability because a coin is fair. So it's 1/2 over 1/2 to the third. And now the question is, well, you have to pay me X dollars. Okay, X. And so it's really X over 8. Okay, so we want the game to be fair. So we want, again, the sum of all of these to be equal to 0. So let's do that. So 2.5 plus 5 plus 37.5, right? And excuse me, I should have noted that since this is from my perspective, I'm winning, but you're actually, you're losing money here because you're paying me. So this should be a negative over here, and this should be a negative as well. So plus 37.5 minus X over 8. So that's plus negative X over 8, which is just minus X over 8, which is equal to, we want it to be equal to 0. So really what we want is by adding all of these together, what this is 37.5 plus 2.5 is 40, 45. So it's 45 is equal to X over 8. And that just means that X is equal to 45 times 8, which is equal to 360. And so now we have the answer. What does X have to be for the game to be fair? Well, X has to be $360. And this game is fair. Now here's some tips to figure out whether you're on the right track, if you have the right answer. One question is, well, did I list all the outcomes? And one way to know that and give it is, well, calculate the probabilities that you've assigned to the outcomes and make sure that they add up to 1, right? Because we want to write down everything that's possible to happen, and one of them we know is going to happen. So the probability that either H1 happens or T1 and H2 happens, or T1, T2 and H3 happens, or T1, T2, T3, the probability of that should be equal to 1. And so you can calculate here that in fact our probabilities do add up to 1. And again, if you want to check again, you can say, well, okay, I found 360. Let me plug 360 for the negative X over here. And let me just run the calculation again to make sure that everything's right. And you'll see that everything is right. And I just want to, before we end, we're done with this question, I just want to say one thing about the Dutch books is that this is a fair game. But even if the you would only pay me, let's say 300 here, right? Let's say that X is actually 300, but then the game is not fair, right? I would actually be at a disadvantage. The game is advantageous for you. But that doesn't mean I'm susceptible to a Dutch book, because I can still win, right? If it lands tails 3 times, I do win something. But in the Dutch book, what happens is that you take a series of bets, and with each bet, you might win a little bit at each time. But if you combine all the bets together, if you say, I take this bet and this one, and you calculate all your winnings, what happens is that at each outcome, you're actually losing money. And so that's bad. Okay, so I will leave it at that, and I hope this video helped, and I'm glad that technology was also our friend today. So thanks so much, and we will see you on Wednesday.